Hello everybody. Today we're going to talk about weather patterns, fronts, and pressure systems. So the first question we have to ask ourselves is, what is weather? The state of the atmosphere at a specific place and time is how we describe it. Well, this also includes the conditions such as air pressure, also known as barometric pressure, wind, temperature, humidity, or the amount of water vapor in the atmosphere, dew point, and it's also affected by the following: differences in pressure, differences in temperature, and differences in the moisture content. So we're first going to look at the formation of air masses. An air mass is defined as a large body of air that has properties determined by the surface over which it forms or where it travels. This means that it must be uniform in temperature and uniform in humidity. Air masses change to some extent as they move away from their source region. There are four major air masses that we will be looking at over the course of the next unit. The generation of air mass heat and humidity follows the following rules. Cold air masses form at high latitudes or over cold snow or ice-covered surfaces. Warm air masses form at low latitudes or over warm surfaces. Humid air masses form over the oceans or very large bodies of water, and dry air masses form over land, typically lower in humidity. The four basic air mass types, therefore, are cold and humid, which are maritime polar, as you can see in the left and right hand side over both of the oceans. Cold and dry, which is continental polar, as you can see coming from Canada into the United States, for example. Warm and humid, which is called maritime tropical, which is coming from the southwest and the southeast towards the United States. And then also we have warm and dry, also known as continental tropical, which is coming over the continent and is also tropical in temperature. So you can see that entering into the bottom portion of the United States. These air masses influence local and regional temperatures and weather patterns. These boundaries between two air masses of different density, moisture, or temperature are known as fronts. These are typically associated with a low pressure system, as you can see in the middle of the diagram. Clouds, storms, and precipitation often occur at these frontal boundaries, and there are also four main types of fronts. The first type of front that we're going to look at is the warm front. This occurs when a mass of warm air moves into an area of colder air. The warm air is gradually forced upward and over the cooler air mass as it approaches. Typically, they travel from the southwest towards the northeast in the United States, and they are slower moving than the cold fronts. Notice in the diagram that there is a gradual slope as the warm air overtakes slowly this cold air underneath. You can see clouds form at the base of the front, and as you can see in the right-hand diagram, the pattern for this warm front, or the symbol on the map that is shown, is a straight line with half circles that are filled in. Warmer air is behind the front line, and colder temperatures are ahead of the line itself. There are typically indicators of a warm front passing. The following will explain that. So the first one is the large change in temperature. You will go from colder temperatures to warmer as the warm front moves into your area. There's a shift in wind direction, typically from a southeasterly direction to a southwesterly direction, as you can see in the diagram. The air is more humid, so dew point rises. We can see that as the dew point rises, it matches the temperature on the upper left-hand side of the weather map symbols. Clouds and precipitation develop as the front approaches just ahead of it. So as we saw in the last diagram, the gradual slope will cause those clouds to develop above the cold front as it slowly overtakes it. The next type of front is the cold front. This occurs when a cold air mass is replacing a warm air mass. The cold air forces the warm air upward along a much steeper slope than as in the warm front earlier. Generally, these move from the northwest to the southeast, and it's the fastest of all the moving fronts. The diagram below shows the cold front overtaking the warm front. The warm air gets forced upward, and typically we get rain and even thunderstorms because of that fast-moving cold front pushing in and overtaking the warm air mass. The colder temperatures on the right-hand side, you can see 28 and 31, will soon overtake the 55 and 62 of the warmer temperatures. The symbol on the map is a straight line with triangles pointing in the direction of the moving front. Indicators for a cold front will be a large change in temperature as well, going from warmer temperatures to then colder temperatures as the cold front moves in. Shift in wind direction from the south-southwest to the north-northwest. Air is much less humid, and dew point actually drops this time. Deeper clouds and more intense showers and even thunderstorms can occur with this type of system. The third type of front is the occluded front. This occurs when a faster moving cold front overtakes a warm front and creates almost a wedge if you were to look at it from the side view. It separates a new cold air mass from an old cool air mass, which was located ahead of the original warm front. As you can see in the diagram, the occluded front is indicated in purple, and it shows intermingling triangular and semicircle symbols moving in the same direction. The warm front is on the bottom right-hand side, and the cold front that has just overtaken the warm front is on the bottom left-hand side. So the cold, drier air moves in. This indicates a mature storm system and is surrounded by a low-pressure system, as we'll talk about later on. Winds typically shift from southeast to south and move to west to northwest in direction. The fourth type of front is a stationary front. A front that is not moving typically develops prior to a low-pressure system development. This marks the beginning of a very young cyclone, and this is the meeting of a warm front, typically to the south because our warmer temperatures come from southern direction, and a cold front from the north. As you can see in the diagram, you've got your semicircles in red facing north, so it's moving from the south, and you've got your triangular cold front moving in the direction towards south, so they are moving in opposite directions in the stationary front. If associated with a low, this can bring really heavy rain for a period of time. And lastly, meteorologists will use these patterns to determine the weather. Weather systems generally move from west to east in our country. This is due to the jet stream mostly. We have high pressure systems that are often associated with fair weather, and we'll talk about that in more detail shortly. The low pressure systems mean cloud formation is possible, and precipitation can occur in all different types and forms. Air circulation around highs and lows helps to determine types of air masses and the resulting impacts on the weather, and movement of fronts affects temperature, dew point, and precipitation. And finally, we'll be using weather maps as the one you can see in this diagram to help determine what sort of weather patterns will be forecasted for the next few days. As you can see in this particular weather map, we have something called isobars, which remember are the measurement in millibars of the barometric or atmospheric pressure. This is also indicated by the blue H's, which are your high pressure systems, and the red L's, which are your low pressure systems. You can also start to see the fronts that we just talked about. You've got a cold front off the east coast of the United States in the Atlantic Ocean. Just above it, you'll see a red warm front moving north, and behind it, just below Massachusetts and into the mid-Atlantic states, you'll see an occluded front in purple just above that low pressure system. As we move west, we see another low pressure system with a warm front associated with it moving north, and just southeast of it you'll see the just tip of a cold front that's moving to the southeast. There's also precipitation on this map. All the different colors that you see on the left hand side are indicated on the map with various levels of precipitation throughout the country. We also will be using the weather symbols and learning all the different numbers and symbols around that weather map symbol that helps us to determine what's going on in that particular area. So although this looks like a busy little map, we will be learning how to read this very soon. Thank you for listening, and don't forget to do your whisk.